So basically the PAL structure was consisting of what? An AND array and an OR array, right? So we were discussing in the last class about PALs, and one of the example was PALL 16L8. That is a 16 inputs and 8 outputs, right? So registered output, how it would be? So at the output side, you have the register there. So today we'll study the next one, that is GAL. So compulsorily you will get either either 16 or 8 or this generic logic arrays for 10 to 12 marks. Okay. So you can see the structure here. Generic GAL stands for generic array logic. All of you are with me, right? Class is full silent.
Yes, ma'am.
Yes, ma'am.
Generic array logic. So in short, it is called as GAL. So internal structure and organization of GAL. This example you see there, GAL 220V 10 component. Right, GAL 220V 10 component. So this is programmable output logic macrocells, OLMC ada nodri. OLMC is programmable output logic macro cells. Output logic macro cells. They are programmable. Means what? You can erase the data and you can reprogram. So either you can store 0 or 1 or you can erase it also. So programmable output logic macro cells, OLMCs are there, right? Use E-square PROM technology. That means electrical erasable programmable ROM technology is used. That means programmable means what? You have to erase and you have to reload, right? So what kind of technique is used? Electrically erasable PROM technology is used, right? So either ultraviolet or electrically erasable. So you can see there all the each input you can see there. So each input, how it is being connected there? Two types. One is any non-inverting input, another one is inverting input with a bubble, right? So non-inverting, inverting, non-inverting, inverting, non-inverting, inverting. So this is programmable AND array. So that AND plane, like in the previous slide what we had seen, see, now this AND array or array and all will not be seen. Directly each input will be represented as, see there, this is x1 and through NOT gate it is going. So here you have x1 bar. So directly what is being done? Just an non-inverting input and an inverting input. So this is being connected to a externally to a pin. So inputs are represented like that. So if I say this is I1, so this will be I1, whereas this will be input 1 bar, right? So like this, the inputs are shown. Okay. Then in the next slide, you see, here also, we had shown all this AND arrays and OR array, everything was shown here in 16, in PAL 16.8. But as you go to the higher versions, what is being done? Higher versions, what is being done here? What is being done? Directly a pin and its non-inverting and inverting inputs in a box where only it is written as programmable AND array. So all the AND gates will be there inside here, and OR array, right? So the output logic OLMC, output logic is shown directly, the output pins are connected. So what will be there in OLMC? Those register will be there. and all that. We will see the depth of the OLMC here, right? So they are program. So OLMC is nothing but what? Output logic macro cells, right? So you can see here generic array logic, that is GAL. GAL components provide output logic macro cells, OLMCs, that replace the combination of OR gates, registers, and tri-state drivers in PAL output circuits. So this is very important. So inside OLMCs, what all will be there? An OR gate will be there, and a register will be there, right? And tri-state drivers will be there. Tri-state drivers, right? So all this will be put up in a box, and this we are calling it as OLMC, output logic macro cell, right? So instead of showing all that, so if you go to the previous slide, in PAL, one second. So whatever in this PAL, this was there, all this thing will be inside an OLMC, output logic macro cell. So what all will be there? So register, because registered output you need, right? So from the AND array, you need an OR array. So OR array and register, and this tri-state buffers will be there inside the OLMC. So generic array logic. Generic array logic components provide output logic macro cells that replace the combinations of OR gates, registers, and tri-state drivers as shown in PAL output circuits. Each OLMC includes circuit elements together with programmable multiplexers. Along with that, what will be there? Programmable multiplexers will be there. So to select between the different outputs, you want plain output, you want registered output, or you want inverted output. So you need to select, right? So in that case, you need a multiplexer. So multiplexer is also used, right? If four inputs are there, how many select lines you need? If you want to select between four, then how many select lines you need? How many select lines you need? If you want to select between four combinations, how many select lines you need? Can anybody answer me? Or shall we stop the class? All of you are silent. Are you able to hear me, all of you? Ankita?
Yes, ma'am.
ಕೇಳ್ಸಕತ್ತತಾ?
Yes, ma'am.
ಮತ್ತೇನು ಎಲ್ಲರೂ ಸೈಲೆಂಟ್, ನೀನು ಸೈಲೆಂಟ್ ಆಗ್ಬಿಟ್ಟಿ? ಮಲ್ಟಿಪ್ಲೆಕ್ಸರ್ ಫೋರ್ ಔಟ್ಪುಟ್ಸ್ನಾಗ ಯಾವ್ದಾರ ಒಂದು ಚೂಸ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಸೆಲೆಕ್ಟ್ ಲೈನ್ಸ್ ಎಷ್ಟು ಬೇಕು?
Two, ma'am.
That's all right. Two select lines. If I have two select lines, simply I drew four there. If I have two select lines, then if two select lines S0 and S1, then I can select four combinations. If I have only one select line, then how many combinations I can select?
Two, ma'am.
Two. That's all. All of you unmute yourself and answer to me. Otherwise, you can leave the class. If you doesn't want interactive classes, simply sit quietly and either listen or switch on and go. Don't want. So uh, what we were discussing. So each OLMC includes circuit elements together with programmable multiplexers. So you have programmable multiplexers to select between the outputs, allowing the output functionality to be determined as part of the programming the component. So figure shows the internal circuit organization of, later we will see. Figure shows the internal circuit organization of GAL22V 10 component, now manufactured by Lattice. So this is manufactured by Lattice Semiconductor Corporation. So you can see there output logic cell OLMC internally how it will be. So from the AND gates, you have an OR gate here. So selection is there. One output, see output of an OR gate. Can you see this, Ankita?
Yes, ma'am.
So output of the OR gate, one is coming through the inverter and which is being connected to the zero of the multiplexer. That means what? This is the inverted output, right? This is inverted output, one output. Another one, if you see, another output is directly connected. It is not inverted. So that is being connected to the one pin number one of the selection, one of the multiplexer. The next one more output is connected to the D latch here. Then from Q it is being connected. That means this is registered output. Through the register it is coming, registered output. This is inverted output. This is non-inverted output. Then next one more is Q bar. The second one which is going back. Whatever the output is there, that is again connected back. Feedback is there. So feedback. If I want the output again back to some sequential circuits, if they want, that it is going here. So this is very important. You can take the screenshots, especially 4, right? That's what is shown here. So you can see figure shows the OLMC circuit for each section. The OLMC has P term inputs from the AND array. So from the AND array, P terms are coming. AND array product terms, like if you have X bar, X2, ORed with something X3, X4, something is there. So these P terms are coming, product terms are coming. Later you will have to add them. So the OLMC has the P terms inputs from the AND array with the same organization as that of the PAL component. PAL component ne heng madidwala ade type ne AND array in the input baratade. The number of P terms ranges from 8 for some sections to 16 for others. So the P terms from AND gate, whatever is coming, either it ranges from 8 to 16, right? The output of the OR gate connects. The output of the OR gate connects to the D flop that has a clock. See there. One second. So these gates, these AND gates could be either 8 or 16, right? So the output of the OR gate is connected to the D flop here, right? So what is there? Reset, preset, and clock is there. Q and Q bar is there. So the same thing is being told. The output of the OR gate connects to the D flip-flop that has the clock, asynchronous reset, which is written as AR there, asynchronous reset, and synchronous preset, right? SP, synchronous preset signals in common with the other OLMCs in the component. So OLMCs will, it has the D flop. The select inputs to the multiplexer, the select inputs of the multiplexers are set by programming the component. So you can program and you can set the multiplexers. The 4 input to the multiplexers allows the selection of registered or combinational output, either inverting or non-inverting. That's what I showed. Either you have inverting, non-inverting, or through the register. So this multiplexer is programmed to have any of kind of the output. Directly output here, directly for this OR gate, there is no pin directly. It is not done here like that. So what is being done? Okay, I cleared all. So the pin will be here, right? So at this pin output, you can get either inverted output or non-inverted output or registered output you will get. So that is coming through an multiplexer here, right? So the 4 input multiplexer allows a selection of the registered or combinational output, either inverting or non-inverting. The 2 input multiplexer allows either registered or combinational feedback or if the output driver is in the high impedance state, direct input from the component pin. This we had not seen. Where this comes, the 2 input multiplexer. This we saw this was 4 input multiplexer. So now he is talking about the 2 input multiplexer. One is directly output is fed back, directly whatever is coming from the output. So if you want the feedback, the output is directly coming from the output. See here. So either it will be inverted or non-inverted. Or inverted. One, it is directly coming from the pin. Another one is coming from where? Q bar through an combinational circuit from here. Right? Another one is coming. So that is two input multiplexer. So 2 input multiplexer is used for feedback, right? So in some sequential circuits, if you want the feedback back, so this will do the job of feedback, right? So that's what is told. The 2 input multiplexer allows either registered or combinational feedback, or if the output driver is in high impedance state, direct input output, this one, if it is in high impedance state. That means what? If this is not being activated, it is an active high input, right? So output is one active high tri-state buffer, which is coming from an AND gate. So if it is in high impedance mode, when this will be in high impedance mode, that means if it is not 1. So if it is in high impedance mode, means this path is not active. So in that case, directly it is going to the feedback. This line is activated. So the 2 input multiplexer allows either registered or combinational feedback, or if the output driver is in high impedance state, direct input from the component pin is given. So there is one example design of priority encoder that has 16 inputs 0 to 15, a 4-bit encoded output. That is this priority encoder already we have done, and a valid output that is 1 when any of the input is 1. So this you have to design. The design is to be implemented using GA22, 22 inputs and 10 output component only. So this you can do at home. Textbook is there. The next is CPLD.